Okay, in this video I'm going over number 6 from the non-calculator, paper 1 that we took. We have the derivative of f given to us, and we're asked to find f of x. So at the beginning you need to realize that integrals are what get you from a derivative to an original function. So I'm not trying to get the derivative, I'm given the derivative. If I'm trying to go back to the original function, I have to integrate. And then this information is so that when I do the integration, I'll be able to find a specific c value rather than leaving it as the general plus c. So setting up an integral. It's a general integral, right? It's not definite, so it's an indefinite integral. And this is the thing I'm trying to integrate. And then I just have to remember to put a dx next to it. So a point for noticing that you have to integrate and setting up this integral correctly. Then the actual integration of this is pretty tricky. So I want to use u substitution. It requires that we remember what this means. If we have a sine cubed 2x, it means sine 2x quantity to the third power. Okay? It means that the sine function is being cubed. So I'm going to let u equal sine 2x. du, therefore, which is the derivative of whatever I've just defined u to be, is going to be cosine 2x, right, because the derivative of sine is cosine, times 2, because it's the chain rule, and the derivative of 2x is 2, times dx. Always have to put that dx when we're doing du. Now, if I look up to the original function, I see that I can now swap out this term, the sine cubed 2x, with u cubed, and the rest of what remains is cosine 2x dx, which is almost what I have down here in du. So I can almost swap it out for du directly, except for that I need to get this 2 moved to the other side. Okay, so I'll be able to swap out the rest of the expression with du over 2, or 1/2 du. So now I'm ready to integrate. Oh no, so I'm going to replace it with u first, then we'll integrate. So when I replace it with u, this will be u cubed. This will be 1/2 du, and all of this is multiplied together. Now I'm ready to integrate, and when I integrate, that 1/2 is like a coefficient that just stays there. U to the third is easy to integrate as u to the 4th over 4, right? This is multiplication, and the du drops out. I do have to remember to put a plus c. And then I'm going to put my u substitution back in place. So u was supposed to equal sine 2x, so if I put that back in place, it's going to be sine to the 4th 2x, let's say over 8, because I have 2 times 4, and then I have this plus c. So here is my function generally, and then I have to go back up and look at that other information that was given. I have f of pi over 4 equals 1. So this is my function, f of x. That's what I get when I integrate f prime of x. I get f of x, a function for x. I have f of pi over 4 equaling 1. So I can change y to 1 when x is pi over 4. And it looks a little complicated, but it's going to simplify pretty nicely. And there's this plus c over here. That's my goal, is to figure out what that c should be, since everything else is filled in. Well, 2 times pi over 4 is just pi over 2. So this is the sine to the 4th power of pi over 2 over 8 plus c. Sine to the 4th power of pi over 2 means do the sine of pi over 2, and pi over 2 is 90 degrees. So if you think about the sine of 90 as y over the radius, at a 90-degree angle, the y value is 1. So the numerator of this is just 1 to the 4th power, which is 1. So 1/8 plus c. Subtract 1/8 from both sides, and 7/8 equals c. So now I can write the final function as sine to the 4th 2x over 8 plus 7/8, or some simplified version of that. And that is all.